All right, guys, let's go ahead and go over the questions from the Unit 1 review. All right, so we're going to have kind of different questions kind of come in and out in terms of the order may not always be the way in which we discuss them in class, but I'll try my best to help you with these. And come see me in office hours if you're confused after watching these or doing them so we can make sure you're ready for our test this week. Okay, so given these functions below, we want to evaluate and simplify depending on what they're asking us to do. So the first one says to do f of a minus 2, which means I'm going to put a minus 2 where it says x. All right, now when I do this, this is where we're going to have a binomial squared. So we talked about this in class. You can always just write a minus 2 twice and then distribute, but I want you guys to work on trying to do this more efficiently. So take the first term and square it. Take the second term and square it, but leave that space because a times negative 2 is negative 2a, but then you got to multiply by 2 to get negative 4a. So that's the middle term. Then I'm going to distribute this 2 to get 2a minus 4 and then write minus 3. All right, getting my like terms together, I have negative 4a plus 2a, which is negative 2a. 4 minus 4 is actually 0, so just bring down the minus 3. So the answer here is going to be a squared minus 2a minus 3. All right, let's move to the next one. This is a little bit different because we're setting a function equal to a number 6. So we're write 6 equals x plus 5 squared minus 7. I'm going to move that minus 7 over with addition to get 13 equals x plus 5 squared. And you're going to see this kind of thing happen when we do our unit on quadratics, solving with completing the square. So right now this might be a little bit confusing, but it's good practice for when we get to that solving with completing the square. I'm going to take the square root of both sides to get rid of that square symbol. Now when I do that, I need to make sure that I put plus or minus in front of that square root of 13. And then this is just going to be x plus 5. We talked about in class last week that when you use the square root symbol on something that is squared, those are inverse operations, so they kind of undo each other. So we just have x plus 5 on the right side. Move that 5 over with subtraction, and you get negative 5 plus or minus the square root of 13. Feel free to go into a calculator and type in negative 5 plus the square root of 13 or negative 5 minus the square root of 13, and you can use a decimal if you'd like. All right, but this is totally fine. You can leave it like this. Okay, number 2, it wants us to look at these different graphs, determine if we have a function or not, and then look at explaining it why, if it's not a function. And we'll do the domain and range, even though it doesn't really state to do the domain and range. If it's not a function, we can go ahead and do the domain and range. Okay, so the first one is definitely a function because it passes the vertical line test. There's no point, it's not like a long function, but there's no vertical line that hits more than 1 point. So yes, it is a function. It passes the vertical line test. For the domain, this is going to be a little tricky here. So we're going to have multiple intervals going from negative 4 to negative 2. And I'm not sure why I put a parentheses there. I apologize. That should be a bracket for negative 4. And then negative 2, though, is going to be a parentheses. It's not included. Then you use this little union symbol to show we're going to continue. The next one would be negative 2 to positive 1. Both of those are open. And then we have another stretch of domain here that's going to be 1 to positive 5. And that 5 is going to be closed, a bracket. Okay, so we have 3 different pieces of this interval notation for the domain. For the range, we are actually just going to have one of them. All right, we're going to have positive 2 is the lowest y value included all the way up into positive 6. And both of those are going to be brackets. Okay, now let's go to the next one. Now the next one here is not a function. All right, it fails the vertical line test. I'll give you an example. Looks like it x equals 2, this vertical line. Hits 2 points right there and right there, so that is going to fail the vertical line test. It is not a function. In terms of the domain, though, we're going from negative 2 all the way until positive 4. And I know we have open circles, but what you should notice is that the where we have open circles, we have closed values as well. right? So it's not going to be an issue in terms of needing more than 1. So -2 to 4 is fine. For the range, our lowest y value is going to be -4, going up until +1, but you'll notice we actually don't have an included y value of 1 ever in terms of this relation, so I'm going to have to use that union symbol again to do a second interval notation for 1 to 5 for the rest of the y values. Okay, so that's it for part B. Let's keep going. All right, so we have this graph here that we're going to transform. So the first thing I want to do is actually go down to this original table and create these points here. So we have -1, 2, 3, 4, 5, -6, comma 4. Then we have -3, comma 2, 0, comma 6, 3, comma 0, and finally 6, comma 3. So this is what we're going to be transforming. Based on these different values that I see a -4 after the function, so that's going to be 4 units down. And then I also see this 1/2 in front, so we call that a vertical compression because that value of 1/2 is between 0 and 1 of a factor of 1/2. I'm actually going to put vertical compression by a factor of 1/2. Okay, so let's write down what this is going to do to the different values. So we're actually not going to change the x. There's nothing happening inside the parentheses with this function, so this is going to be the same. But we are going to have new y values. We're going to divide them by 2 or multiply them by 1/2 and then subtract 4. That'll take care of both of those transformations. So copy down the same x values, but we're going to do these quick little operations. So 1/2 of 4 is 2. 2 minus 4 is -2. 1/2 of 2 is 1. 1 minus 4 is -3. 1/2 of 6 is 3. 3 minus 4 is -1. 1/2 of 0 is 0. 0 minus 4 is -4. 1/2 of 3 is 1.5. 1.5 minus 4 is -2.5. So let's plot these points for our new transform function. So -6, -2. -3, -3, 0, -1, 3, -4, and then finally 6, -2.5, which is there. So drawing to connect these like we did, or like the original was, you can see that this right here is our new transform function. Now it does ask us to find the domain and the range for the new graph. So let's go do the domain. The domain is actually the same, right? We didn't change anything about those x values. So it's still going to be -6 to +6. But the range is going to be different because we did move it down and also compress it vertically. So our new lowest y value looks like it's -4. And our highest y value is now -1. Okay, so that's how we transform that function. Okay, let's do some triangles, the stuff from the very first day of school. So in this case, we kind of have 3 things I'm looking out for: using Pythagorean theorem, using SOHCAHTOA, or if you do know your 30-60-90 or 45-45-90, you can always use those relationships when those happen. All right, in this first one, part A, I see we have 2 sides of the triangle. We're missing 1. So I'm going to go ahead and use Pythagorean theorem, which is going to be x squared plus 9 squared equals 12 squared. So x squared plus 81 equals 144. We're going to move that 81 over with subtraction. When I do that, I get x squared equals 63. And again, you can feel free to leave this as the square root of 63, which really becomes, what's that going to be? Square root of 63 breaks down to 9 and 7. And so that's 3 times the square root of 7. So you can leave it as 3 times the square root of 7. Or if you wanted to get a decimal from a calculator, that would be 7.9 approximately. Okay, let's do the next one. Now the next one, I don't have 2 out of 3 side lengths. And also I don't see 30-60-90. So I'm going to be using SOHCAHTOA here. All right, and the idea is when I look at this, I'm looking at it from the perspective of 35 degrees. So x is the adjacent side, and y is the opposite side. All right, I do know the hypotenuse, so I'm going to first use cosine of 35 degrees is equal to the adjacent side x over the hypotenuse. I'll find that. Then I'm also going to use the sine of 35 degrees is equal to the opposite side, or y, over the hypotenuse of 15. So kind of the first thing I'll be looking at for your work is, are you setting up the correct trig function? If you are, then I know that you understand SOHCAHTOA. If you don't, we need to review that. Now the work to find these missing values is the same. I'm going to multiply both sides by 15. And then whatever calculator you're using, just make sure you have it, the mode is in degrees here. That's the kind of key thing. So x is going to be equal to 15 times the cosine of 35 degrees. So x is approximately 12.3. And then same thing here, y equals 15 times the sine of 35 degrees. You guys know I like to use decimals, but you can use any calculator as long as you're in degrees. So 15 times the sine of 35 degrees is approximately 8.6. Okay, so that is it for part B. All right, let's do some more evaluation. Okay, so given the functions below, evaluate and simplify the following. So this one says g of -2. So I'm going to replace that -2 where it says x. So g of -2 equals -2 plus 5, all of that squared, minus 7. -2 plus 5 is 3. 3 squared is 9. And 9 minus 7 is equal to a positive 2. Let's do the next one. The next one, you're going to set h of x equal to 3. So that's 3 equals 21 over x minus 2. You can write this as a fraction, 3 over 1, and then multiply diagonally to get cross products. So 3 times x minus 2 equals 21 times 1. So that's 3x minus 6 equals 21. Move the minus 6 over with addition. 21 plus 6 is 27, so x equals 9. All right, so that's some more work with the evaluation. Okay, let's look at this graph, which we're going to do the same kind of thing we just did, but now instead of having the functions, we're going to look at evaluating graphically. So we have g of -9. So when I go here on my function, I'm going to move in the x direction to -9, and the point on this function is right here, and that's -9 comma positive 4, so the y value is 4. I'm going to try to change colors so you can see if you're following along with the video of how I'm getting these. G of 0, so x is 0, so go to 0 on the x-axis, and then the y value is here, which is positive 3. Next up is g of -5, so go to -5, looks like that point is there, which is a y value of 6. Keep it going. We've got g of 10. G of 10 is the last point here, which is a y value of 5. Okay, now this is where it changes. It changes when it says g of x equals 5. I'm going to draw a horizontal line at 5 and see where it hits. Looks like it hits around here and around there. That one's a little easier at the end, right? That's an x value of 10. And for this first one, I would probably accept anything around -5.5. It's probably -5.4 is my approximation. But again, anything around -5.5 would work for me. Okay? Another one, this time I'll use a different color. We're doing g of x equals 7. So draw a horizontal line at y equals 7. And it looks like the point is going to be this one here. It gets really close. It's kind of hard to tell. It looks like it kind of does hit it at -2. But the one that I'm going to put is -1 for that x value. All right. Now it says, give the domain and the range. So the domain, the lowest x value is -9. And then it looks like we're good. We do jump here. We have a little bit of a break from -1 to 0. So I do need to put -1 And I believe those were closed circles. Yes. So I'm going to close that and then use the union symbol. And I'm going to pick it back up with 0. And then we have to pause here. There's no x value at 5. Use that union symbol to start again at 5 to get to 10. So a lot going on there to find that domain. Okay, the range. The lowest y value is actually going to be 1, but not really because it's not included. And as we move up, it looks like we hit everything all the way from 1, again, not including 1, up until 7 for the range. All right, now, is this a function? And as I look at it, passing the vertical line test, I don't see anywhere where it would fail. So yes, it is a function because it passes the vertical line test. Okay, let's keep going. Let's try number 7. All right, so number 7 is looking at these two different graphs. Kind of similar to what we did, I think, on the second one. We're going to answer some questions about domain and range, and is it a function? Well, this first one is not a function. It fails a vertical line test in a lot of places, but definitely at x equals 1. It fails it right here and right here. That's 2 points, so no, not a function. It fails the vertical line test. In terms of the domain, the lowest x value is -4, and then all the way until it looks like until 3, but then that 3 is not included, so I'm using an open parentheses. In terms of the range, the lowest y value is an open circle for -5, it's not included, all the way up into almost 5, right? We use 5 with a parentheses because it's not included. Okay, let's try the next one. The next one is a function. It looks like it passes the vertical line test, so yes, this is a function. And for the domain, our lowest x value is going to be -2, but it's not included. So I put that parentheses, and we're moving to the right forever towards infinity. And for the range, the lowest y value is 1, but it doesn't include 1, all the way up towards infinity. All right, let's do a transformation where we identify the parent, graph the parent, list the transformations, graph the new one, and then do the domain and range for that new one. All right, so the parent function here is absolute value. And that's going to be, this right here is the parent function. Hopefully you remember the original points of -2, -1, 0, 1, and 2. Taking the absolute value of those would be 2, 1, 0, 1, and 2. It creates that V. So let me graph that V for us. Remember, this is the original or parent function, so nothing has happened to this. This is the most basic version of that absolute value. Okay, now we are going to do something to it. We are going to do, looks like 2 transformations. I'm going to have a -3 inside, which is a horizontal shift, and a -2 on the outside, which is a vertical shift. So I'm going to write down 3 units to the right, thinking the opposite of -3 is +3. So that's 3 to the right, and then the -2 outside is going to be 2 units down. All right, so what we've practiced in class and what I want you to make sure you know how to do from watching this video or getting help is you've got to know how these transformations are affecting your new x and y values, okay? This one is probably straightforward enough. You could probably just take those 5 points that I plotted and move them 3 right and 2 down individually, right, one at a time, and you could graph it. But I want to make sure you know the process here. So if it's affecting horizontally, right, the x-axis, we need to take all of our x values and move 3 to the right, which is going to add 3 to those x values. Then the 2 down is going to affect the y values, so we take all of our y values and we subtract 2. So I'll be looking for that on the work that you do for the test to make sure I see that you're understanding how the transformations are affecting the new table. All right, so let's add 3 to all of those. -2 plus 3 is 1. This is going to be 2, 3, 4, and 5. And the new y values are going to be 0, -1, -2, -1, and 0. All right, so we plot those. And again, it should look like a V, just in a different location. So here is the new function. It should look just like the original, but now it is in a different location. Let's find the new range, new domain. The new domain is actually going to be the same as the original domain. You can plug in any x value here, so negative infinity to infinity. And the new range is different. With the original one, we couldn't go below 0. Now our lowest y value is -2, all the way up into infinity. Okay, let's keep it going. Now, we've done 2 questions like this, but both were with graphs. Now they're giving us some function mapping, where we're going to determine if these are functions or not and do the domain and the range. You'll notice with the domain and range here, I will not be using interval notation, even though it says to, because we do not have values in between that are part of the domain, so I will be using roster notation to list it out. All right, so is this one an a function? If I'm assuming these are the x's and these are the y's, I just need to be on the lookout for any x value being drawn to a second y value. And I don't see 2 arrows coming out of any of the x's, so yes, this is a function, right? It would pass the vertical line test if you plotted these points on a coordinate grid. For the domain, I'm going to list it with braces. We have -1, 0, 4, 7, 8, 12, and 13. And then for the range, I have -6, -2. I know it's happening twice. You don't need to list it twice. Then 5. Notice I'm not listing 6 because there's no arrow going to it. So I have 8 and then 17. Okay, let's move to the next one. Again, I'm going to assume that this is x and this is y. All right, so we're going to have, is it a function? Do I see 2? Uh-oh, I do. It looks like right here, -9 is going to -16, and -9 is going to 9. So that's like these ordered pairs. If you were to plot -9, -16, and -9, 9, that would fail the vertical line test. That would be 2 points on the same vertical line, so this is not a function. For the domain, I'm going to list -19, -14, -11, -9, 2, and 4. And then for the range, I'm going to list -16, -13, -11, -9, 9, and 10. Okay, I'm going to pause here. Hopefully you'll pick it up with part 2.